In this video, I'm going to be going over an introduction of angles, the different types of angles, and how we can measure angles. So first, a couple of definitions. So first we have a ray, which is a part of a line made up of a point, which is called the endpoint, and all points on a side of the endpoint. So we would draw a ray like this, start with an endpoint, and then it continues on forever. And we would name this ray with that endpoint. So this would be ray A. Sometimes we'll have a point somewhere along the ray, so this could also be named ray AB. In shorthand, we would write it like this. So AB with an arrow with only one direction on it. Second definition we have an angle, which is two definitions we can use. First is the rotation of a ray about its endpoint, and then the second definition is the union of two rays at an endpoint. So thinking about that first definition, the rotation of a ray about its endpoint. So suppose we have a ray and we rotate it. Let's say we rotate it in the counterclockwise direction, so it ends up here. So the initial ray and then the rotated ray together form an angle. Or we can say if we have two rays that are joined together at the same endpoint. So that's a second way we can define what an angle is. So we want to talk about how we can name an angle. So there's a few different ways we can name an angle. Typically, we want to talk about 3 points on the angle to use for the name. So if I have this point A, B, C, I could name this angle ABC. We could also call this angle CBA. Okay, as long as this point B, which is called the vertex, as long as that is the middle letter in how we name these angles with these 3 points. If we just have a single angle, we could also just call this by its vertex, so we could call this angle B. We would not want to call this angle A or angle C because neither of those points are the vertex. Now, we need to be careful if we have something like this. So let's say we have 3 rays at the same endpoint. So let's say A, B, C, and D. We would not want to call any of these angles, for example, let's say I'm talking about this angle. We would want to call that angle BAC or angle CAB. We wouldn't want to call that angle A because angle A is the vertex of 2 different angles. It's the vertex of BAC, that first angle we were talking about, but it's also the vertex of this angle. So in this case, when we have 2 angles we're talking about, we want to be sure to use 3 letters to describe that angle. Next, we want to talk about the different types of angles. We could have an angle that is less than 90 degrees. We call this an acute angle. And that's just less than 90 degrees. We can have an obtuse angle, which is anything greater than 90, but less than 180. So an obtuse is going to be an angle, let's call this angle A. Angle A is greater than 90 degrees, but less than 180 degrees. We could have a straight angle. So a straight angle is an angle that equals 180 degrees. We could also have a right angle. That is an angle that measures exactly 90 degrees. So those are the main types of angles we're going to be seeing in a trig or a pre-calc class. Now there are a few different, 2 different ways that we would measure an angle. We already mentioned degrees. A second way that we will measure angles is with something called a radian. We'll talk more about radians here in just a second. But with degrees, oftentimes we will think about degrees having to do with a circle. So it's commonly known that there's 360 degrees in a circle, and the reason we have 360 degrees in a circle is because people used to think that 1 year was 360 days long, and so it was known that the Earth traveled around the Sun, and it was believed that it took 360 days for the Earth to travel around the Sun, and that's actually a pretty good estimate because we know it's about 365 days. So that's where 360 degrees comes from. Get rid of the Earth and the Sun. So oftentimes we will have an angle that is centered at, or its vertex is centered, or I should say its vertex is placed at the center of a circle. And this type of angle is called a central angle. Central angle. And again, that's just an angle that is centered, an angle whose vertex is at the center of a circle. This is a very common thing that we'll be talking about in this class, central angles. So oftentimes we'll place an angle, place an angle's vertex at the center of a circle. We also call this type of angle an angle that is in standard position. Standard position. Now, when we're talking about angles in standard position, we call this ray of the angle the terminal side. Okay. Another way of thinking about that is the starting side. So if we're thinking about an angle, if we go back to the definition that we had at the very beginning, this definition right here, an angle is the rotation of a ray about its endpoint. Now, if we have a ray here, let's call it the terminal side, let's say we rotate that counterclockwise. So let's say I rotate that ray and then it ends right here. Okay, so that angle has been, or I should say that ray has been rotated counterclockwise and to form a new angle. And that angle we would say has a positive measure. And we don't know exactly what that measure is, but it looks like it's more than 90 degrees. It's not quite straight, so something between 90 and 180 degrees. So it would make sense for this angle to be, 150 degrees, for example. Now, if an angle is, if a ray is rotating clockwise, in that instance, the ray has a negative measure. So let's say it comes up here. Okay, so this is going to have a negative measure. Okay, so this actually looks like it's gone, over here it looks like we have 90 degrees, so we know all the way around the circle is 360, so about 360 minus 90. This is about, it looks like this ray has gone 270 degrees, but it's gone in the clockwise direction, so we would say this is a negative 270 degrees, for example. All right, so let's talk about radian measure. The definition we have is 1 radian is the measure of a central angle of a circle that intercepts an arc of equal length to the radius of that circle. So let's see what this means. So we have a circle. This length here is called the radius, the distance from the center to the edge of the circle. Now, suppose this distance, whatever it is, this distance r, and let's give it an actual value. Let's just say it's 2, whatever unit you want to choose. Now, let's suppose I walk along the edge of this circle a distance that is also 2. Okay, so whatever the radius of the circle is, I selected 2, and I walk along the arc of the circle, no, not 12, a distance of 2. Now, this angle, this central angle, right, the vertex is at the center of the circle, that angle here is equal to 1 radian. So this angle is equal to 1 radian. So that's what a radian is. It's the angle that's created when we have the arc length here, which is 2, equal to the radius. So the radius is going to be 2 no matter where we are on that circle. So let's look at a bigger circle. All right, so now here, this radius is going to be bigger than 2. Let's say it's 5. Okay, so now I need to go an arc length that is also 5. Well, it's going to be bigger or longer than that previous circle, but here we say that this radius is 5. Well, what we see is this central angle is going to have the exact same radian measure, right? This angle here looks about the same as the angle over here. It's still 1 radian. Okay, so, and if you look at this, if we kind of map this out, it's going to come out to be a little bit more than 6 of these sections or pieces of the pie in the circle. So it's going to be like this, like this, like this, and then we'll have a little bit of a slither. So 1, 2, 3, 4, 5, 6, and then a little bit extra. And we'll see kind of how this relates to degree measure. But it looks like this is a bit more, this is a very scientific definition, a bit more than 6 radians in a circle. So the last thing in this video that we're going to talk about is how to convert between an angle in radians and degrees and vice versa. So we just said down here that it looks like there's a bit more than 6 radians in a circle. And so precisely it's 1 circle is equal to about 6.28 radians. And so that's about, because it doesn't come out, that's a rounded number. But precisely 1 circle is equal to 2 pi radians. Okay? Pi is just a number. That just means 2 times 3.1415, etc., etc. Okay? So that's why this is a rounded value. 6.28 is rounded. But 2 pi is a precise value. So 1 circle has 2 pi radians. And we know that 1 circle in degrees is equal to 360. So what we would say is 2 pi is equal to 360 degrees. So here's our main conversion. So 1 circle, if we're measuring the angle around a circle, that's going to be equal to 2 pi, and that's in radians. Or that's equal to 360 degrees. So when we're talking about degrees, we need the degree symbol. Okay. When we're talking about radians, oftentimes we will write the word radians. But if it has pi in it, that's understood to be a measurement in radians. So what we want to do is we want to be able to convert an angle that is in radians into degrees and vice versa. So let's look at a couple examples here. So let's say I have an angle that's pi over 3, and I want to convert that into degrees. Well, pi over 3 is in radians. Again, it doesn't say radians, but because it has the pi, that tells us it's in radians. So what we do is, well, we see here that 360 degrees is equal to 2 pi. So our conversion factor is 360 degrees over 2 pi, which is the same as if I divide the numerator and the denominator by 2. get 180 degrees over pi. So I would use this conversion factor, or I could flip it, and it would be pi over 180 degrees. So whatever we want to get to, we want that unit in the numerator. So here we have pi over 3, back to our example. We have pi over 3 radians. We want to get to degrees, so I'm going to write degrees in the numerator. So when I multiply by 180 degrees over pi, that's just equal to 1. So the pi's are going to cross cancel here. I get 180 degrees over 3, which is 60 degrees. So pi over 3 would be equal to 60 degrees. The second one, we have 3 pi over 4, same deal. I'm going to multiply by 180 degrees divided by pi. The pi's cancel. This one's a little bit more challenging. I could cross cancel the 180 and the 4. I can divide both of those by 2. I get 90 and 2. So 3 times 90 is 270 divided by 2. That's 135 degrees. And we need to be able to do this without a calculator. The last one, let's pick a different color, 3. So this one's a little bit tricky. 1 radian. Now that does not have pi in it. But again, we want to convert this into degrees. So I'm going to say 1 times 180 degrees divided by pi. Well, without a calculator, it doesn't really seem like I can do anything. 180 degrees divided by pi. But if I type this into the calculator, 180 degrees divided by 3.1415, etc., I get a rounded value of about 57.295775. Let's call it 57.296. And that is in degrees. All right, so pretty straightforward. We need to be able to do these first two without a calculator, so we need to be able to do that with some mental math. And then let's go in the opposite direction. So we have 4 examples. I'll do the first one or two together. So 30 degrees, I want to convert that into radians. So I'm going to write that with the radian measure in the numerator. So 30 degrees times pi over 180. Well, I can first cancel out the zeros, and then 3 divided by 18 is 6. So I get a 1 times pi over 6, which is pi over 6. That's in radians. I don't need to write radians. 90 degrees times pi over 180. I can divide by 10. Oops. Divide by 10 and remove the zeros. 9 over 18 is 1/2. So I get 1 pi over 2. And then I'll let you, why don't you pause it and see if you can get these other two on your own. All right, and then on number 3, we're going to have negative 225 degrees. That comes out to negative 5 pi over 4. So the multiplying to get to that first step is easy, but then you got to reduce. So I first reduced the top and the bottom. What did I do? Divide by 5, I think. And then from there I divided by 9. So divide by 5, divide by 9, the top and bottom. You could also just divide by 45 right off the bat. And because that's negative, when we have a negative angle, what that means is we're moving clockwise. All the rest of these angles in this example so far have been moving counterclockwise. And then number 4, 55 degrees. Well, 55 times pi over 180, 55 pi over 180, reduce 11 pi over 36.